Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll discuss some questions that may be asked on PN junction diode, that is from Module 1 of our course, that is Analog and Digital Electronics. Right? So we have already seen the theoretical concepts and the problematic concepts in all my lectures. So you can just go through them so that you will be able to answer whatever it may be the question that is asked on the PN junction diode. So I hope you all know that the question banks are uploaded in the IARE portal. You can just go through the questions from the question bank. So I'll be discussing how to answer these questions. So first we'll start from the problem solving and critical thinking questions. So you all know that we'll have some problem solving questions and also some long answer questions, short answer questions in our question bank. So first we'll see what kind of problems are asked and how to answer them. So first up, so for solving these problems, first we need to be familiar with all the formulae of PN junction diode, like what is the current flowing through the PN junction diode, dynamic resistance and static resistance, how to calculate and all, we have to be aware. So find the value of find the value of DC resistance and AC resistance of a germanium junction diode at 25 degrees centigrade with reverse saturation current I0 is equals to 25 microamperes and at an applied voltage of 0.2 volts across the diode. So what he asked us to find the DC resistance and AC resistance. So DC resistance is also called as static resistance and AC resistance is also called as dynamic resistance. Right? So what are the values given? I0 value. I0 is nothing but reverse saturation current or leakage current, which is due to the minority charge carriers, or else when the diode is reverse biased, whatever the current flowing through the diode is said to be reverse saturation current. So, and the diode type of diode is given, that is germanium. So, what are the values that are given? First, we need to list out. So, as a germanium diode, so eta value that is equals to 1 and I0 value is given, that is 25 into 10 to the power of minus 6 amperes. And applied voltage V is given, that is 0.2 volts. And the temperature T is given, that is 25 degrees centigrade. So first of all, for the temperature given, we need to calculate VT. VT is equals to 25 degrees centigrade plus 273 divided by 11,600. So that is KT by Q. So VT is equals to K capital T divided by Q. So K is a Boltzmann's constant, Q is the charge of electron. So where T is a temperature in Kelvin, so that can be calculated by adding just 273 to it. So calculate this VT, it will be of the order of millivolts. And we know the current flowing through the PN junction diode, either in forward biased or reverse biased, can be represented mathematically as I is equals to I0 into e power V by eta VT minus 1, where eta is 1 for germanium and 2 for silicon diodes. VT is the volt equivalent of temperature minus 1. So this is the equation. So what he asked us to find, he asked us to find DC resistance and AC resistance. So we all know that the DC resistance is given by the ratio of voltage applied to the current. So we know the voltage applied, we have to know the current given. So for that, take the current equation, substitute all the values. This is known, eta is known, VT is known. Substitute and find out I. Substitute this so that you will be getting DC resistance or else static resistance. And you know that dynamic resistance, small r, is equal to the inverse of slope of characteristics, VI characteristic curve of PN junction diode is given by eta VT divided by I0 into e power V by eta VT. So this is a formula for calculating dynamic resistance. Substitute all these values, I0 known, V known, Veta known, eta known. So substitute, then you can calculate dynamic resistance. So you need to remember this formula and this formula for solving this problem. Now find the value of DC resistance and AC resistance for a germanium junction diode at 25 degree centigrade with reverse saturation current I0, 5 microamperes, and at an applied voltage of 0.2 volts with across the diode. So what we need to do? So the same kind of problem. Voltage applied is given, V is 0.2 volts and I0 is given, that is 5 microamperes, and then temperature T is given, that is 25 degrees centigrade. So eta value is also given, that is 1. So just substitute in this equation, get the value of current and find out the static resistance by substituting this V and I, and dynamic resistance substituting all this value. Eta Vt by 1 I0 into E power V by eta Vt. Now the reverse saturation current of a silicon PN junction diode is 10 microamperes. Calculate the diode current for the forward bias voltage of 0.6 volts at 25 degrees centigrade. Okay, so here what are the values given? I0 is given, eta value. It is mentioned that it is a silicon PN junction diode. So that means we need to consider eta value as 2 and V is 0.6, voltage applied is 0.6, temperature is given, and the Vt value we have to calculate by using formula T by 11,600. So what he asked us to find, calculate the diode current. Diode current we need to calculate. Just substitute all these values in the diode current equation. I is equals to eta by E power V by eta n minus 1 into I0. So for this formula, you will get some marks, and if you get the exact value, then you will get full marks. So this is the third question. Determine the value of forward current in the case of PN junction diode with I0 is equals to 10 microamperes, Vf is 0.8 volts, and T is 300 Kelvin using silicon diode. So what are the values given? I0 given, eta value is 2 for silicon diode, Vf value, that is a forward voltage applied to the diode, is 0.8, and temperature 300. Just calculate this one. So substitute so that you will be getting the current. Now the voltage across a silicon diode at room temperature of 300 Kelvin is 0.7 volts. Sometimes he may not give you the value. Room temperature means you should identify that it is 300 degree Kelvin. That is in centigrade, it is 27 degrees centigrade. Okay, 0.7 volts when 2 milliampere current flows through it. Okay, so the voltage across the silicon diode at room temperature of 300 Kelvin is 0.7 volts. Voltage is given and the current is also given. If the voltage increases to 0.75, evaluate the diode current, assuming Vt is equals to 26 millivolt. So here you know that for 300 degrees centigrade, if you substitute the value here, T divided by 11,600, you will get 26 millivolts. Right? So now, as we all know the Vt value and then eta value known and I value, the current flowing for the applied voltage of 0.7 is known. So now, we what we need to do? We have to calculate. We don't know the I0. If you could know the I0, then you can easily calculate the current flowing at when the output voltage, when the input voltage is 0.7 volts. As eta value is known, and Vt value is known, everything is known. If I want to calculate this, first of all, I should calculate I0. So use the formula and substitute I value, V value, eta value, calculate I0. If you get I0, then take V is equals to 0.75 and use again same formula, V0 into E power V by eta Vt minus 1. So I0 value is how much you are getting, you will be getting from this expression, and then substitute V value. What is the V value? 0.75. Eta value is 2. Vt value is 26 millivolts minus 1. So that you will be getting the current flowing through the diode when the voltage applied becomes 0.75. Now, we also have some problems on rectifiers. So for solving the problems on rectifiers, we should remember all the formulae of rectifier, that is regarding the full wave rectifier, half wave rectifier and bridge rectifier. So now, in a full wave rectifier, the transformer RMS secondary voltage from center tap to each end of the secondary winding is 50 volts. Okay, so that means the transformer RMS secondary voltage from center tap to each end of the secondary is 50 volts. So that means each end of the secondary volt is V max is equals to 50 volts, right? So now the load resistance is 900, that is RL value is given 900 ohms. If the diode resistance and transformer winding resistance, that is RS is equals to RF is equals to secondary winding resistance together have a resistance of, that is RS plus RF is equals to 100 ohms. RS plus RF. So transformer secondary winding resistance and diode resistance together we have, that is 100 ohms. Now determine the average load current and RMS value of load current. We have to calculate. So for that we need to use a formula. You know that maximum current IM for a full wave rectifier is given by Vm divided by Rs plus Rf plus RL. Similarly, the average current is given by 2 Vm by Rs plus Rf plus RL, and so RMS voltage across the load resistor IRMS is equals to Im by root 2. First we need to find out V max. So it is RMS value given. Okay, RMS secondary voltage given. So first of all, VRMS is equals to Vmax divided by root 2. Okay, so from this you have to calculate Vmax value. Vmax value is VRMS into root 2. VRMS value is how much? That is 50 volts into root 2 is 1.414. So once you know that, substitute this Vm here, and Rs plus Rf is given, that is 1000 ohms, and RL value is also given, that is 900. Just substitute and get the Im value. Once you got this, substitute this, get IDC, RMS, substitute. So this is the problem. Now coming to the next one. A half wave rectifier is used to supply 24 volts DC to a resistance load of 500. That means what is given here? VDC is given, that is 24 volts, to a load resistance RL is 500 ohms. And the diode has forward resistance of 50 ohms. That is RF value is 50 ohms diode resistance. Calculate the maximum value of AC voltage required at the input. AC voltage required at the input. So what is given? VDC is given, RL is given, RF is given. So as VDC is equals to, this is a half wave rectifier, Vm divided by pi into RF plus RL, right? RF plus RL. So from this one, I can calculate Vmax value. So as we know that Vmax can be given by VDC into pi into RF plus RL. Just substitute all these values so that you will be able to get the output voltage. That is the maximum voltage. Maximum value of AC voltage required at the input. So this is how you can get the maximum voltage. Okay. So next, in a full wave rectifier delivers 50 watts to a load of 200 ohms. If the ripple factor is 0.01, calculate the AC ripple voltage across the load. So what are the values given? DC delivers 50 watts to load. So always you remember the power delivered to the load in a rectifier is DC power. So we can represent that power delivered to the load as PDC, which is equals to 50 watts. And the load resistance is also given, that is 200 ohms. And the ripple factor gamma is given 0.01. Now calculate VRRMS, that is AC ripple voltage across the load resistor. So as we all know that in a rectifier, whether it is a full wave rectifier, half wave rectifier, the output consists of, AC plus DC. So AC components are always represented as RMS value. So he asked us to find out the amount of AC components present in the output. So as we all know that the formula for PDC, we can calculate it as VDC square by RL. That is the power delivered to the load. So V square by R, so that is VDC square by RL. So we have to find out VDC value from this one. We need to find out VDC value from this one. So as you know the formula for gamma ripple factor as RMS value of AC component to the average or else DC value of output. So that is VRRMS divided by VDC. As we know that gamma is 0.1, VRRMS we have to find out, and VDC you will be calculating from this one. So VDC value you know, so just substitute and find out VRRMS. VRRMS will be 0.01 into VDC. Okay, so that is how you can calculate the VDC value. Now determine the dynamic forward and reverse resistance of PN junction diode, silicon diode, when the applied voltage is 0.25 volts at 300 degree Kelvin with the given I0 is equals to 2 microamperes. So what are the given here? Applied voltage 0.25 volts, temperature 300 Kelvin, I0 is 2 microamperes. Now he asked us to find dynamic resistance, dynamic forward and reverse resistance. Dynamic forward resistance means, so the formula is applicable for both forward bias condition and reverse bias condition. Only the thing is, we should be considered as positive for the forward resistance for calculating the forward resistance, and we should be considered as negative for calculating the reverse resistance of PN junction diode. So the same formula is applicable for calculating reverse and reverse dynamic resistance and forward dynamic resistance. Only the thing is, we need to consider the V as positive for forward resistance and V as negative for reverse resistance. What is the V value? 0.25. Consider V value as plus 0.25 and calculate RF. Similarly, consider minus 0.25 and calculate RR. That is reverse dynamic resistance, forward dynamic resistance. Right, that's it. Next, at 230 volts 50 hertz voltage is applied to a primary of a 4/1 step down transformer used in a bridge rectifier having a load resistance of 600 ohms. So what are the values here given? So the turns ratio is given. So that is N1 to N2 is given, that is 4/1. So similarly V1 by V2 we need to calculate. So N1 by N2 is equals to V1 by V2, right? So transformer used in the bridge rectifier is having a load resistance RL of 600 ohms. Assuming the diodes to be ideal. Ideal means forward resistance is 0, reverse resistance is infinite. So ideal, determine DC voltage, DC output voltage, DC power delivered to the load and DC power delivered to the load and PIV and output frequency. So DC output voltage. In order to find the DC output voltage, so what is the formula? VDC. It is a half wave rectifier, half wave or full wave, bridge rectifier. Bridge rectifier 2 Vm by pi. 2 Vm by pi, right? And he didn't mention that internal resistances of transformer, secondary and diode. So that means we need to consider them as 0. So that is why 2 Vm by pi. Next, and for that, first we need to find out Vm. How to find out Vm? In order to find out Vm, we have to take the AC voltage applied at primary. So that means VRMS at primary is equals to 230 volts. So use the formula here. Now you can calculate V2. V2 is equals to, so that is V1 by V2 is equals to N1 by N2. Now I am finding V2. V2 value can be calculated as V1 into N2 by N1, right? That is 1 by 4. You can calculate this one. So this is actually RMS value. So now I want to calculate maximum value. So that is V2 RMS divided by root 2. Sorry, not root 2. VRMS is equals to Vm by root 2, right? So this one will be into root 2. Okay. So that you will get the value here, right? So now after getting Vm, just calculate the maximum current. So maximum current formula is Vm by Rs plus 2Rf into 2Rf plus RL. So why? Because we don't have center tapping in a bridge rectifier. So it is better you draw the circuit diagram. Whatever the rectifier, if any rectifier problems are asked, just draw the circuit diagram so that you will get some additional marks, right? Draw the circuit diagram, write down the formulae and just substitute all the values in the formula. We'll derive all the parameters that are asked. So the DC output voltage is this one and RMS voltage across the load, so is this one. So why I'm calculating all this? Because he asked us to find DC power delivered to the load. DC power delivered to the load is VDC into IDC, or else I can even calculate it as IDC square into RA. Okay. And similarly, peak inverse voltage of bridge rectifier is VM. So these are the formulas that you have to remember. So that kind of problems that may be asked in PN junction diode and also the rectifiers. Now let us discuss some long answer questions. How to answer these questions. Outline the VI characteristics of PN junction diode for forward bias and reverse bias voltages, and represent the static and dynamic resistance of diode in the characteristic curve. Static and dynamic resistance of diode in the characteristic curve, right? Summarize the static, and this is one question, and the same kind of answer can be written for the question, that is summarize the static and dynamic resistance of PN junction diode. Just draw the PN junction diode circuit diagram under forward bias condition. Explain its operation, how the charge carriers are moving depending on the voltage applied to the diode, and how the current is flowing, what is the direction of current flow, and just mention few points regarding the operation of PN junction diode under forward bias condition, and then plot the graph between the input voltage and the input current, that is nothing but the VI characteristics and VI characteristic curve under forward bias condition. Okay, this is the forward bias characteristics. Similarly, draw the circuit diagram of PN junction diode under reverse bias condition. Explain about reverse bias in the PN junction diode, few points, and explain the operation of PN junction diode, how the depletion layer is formed and what happens to the depletion layer, width of the depletion layer when the diode is reverse biased, and what is the operation, how the charge carriers are moving. Either due to majority or minority charge carriers, the current is flowing through the junction. So that kind of some points, few points you just mention, and then draw the graph between the reverse voltage and reverse current. Okay, so this is VI characteristics. Once it is done, he asked us to explain about dynamic resistance and static resistance. You just define dynamic resistance, draw this curve, and mention how to calculate the dynamic resistance and give the formula for dynamic resistance. That means you just derive the formula for dynamic resistance, eta Vt divided by I naught into e power V by eta Vt. Just derive the formula. So that is dynamic resistance. Static resistance, you just define the static resistance and how to calculate the static resistance from the graph you just mentioned. So this is how you can answer that question. Explain the following terms for a PN junction diode. So what are the terms here? Load line, diode switching times, reverse saturation current. So just draw the PN junction diode with a circuit diagram with an external voltage source applied here, and define a load line. What do you mean by load line? How to draw the load line? Just mention the procedure and then draw the load line and explain about operating point. This is for the first one. Diode switching times. Draw the circuit like this, which is used to explain the switching characteristics of diode. And when the input applied is this one, so how the circuit is behaving. So what happens when the input is changing suddenly from 0 to 1 or 1 to 0? What is whether it is changing, the diode is changing its state from perfect forward bias condition to reverse bias condition or not, or it is taking some time. If it is taking some time, what it is called. So just mention all the various time specifications of PN junction diode, like storage time, transition time, forward recovery time, reverse recovery time, with the examples and waveforms. You just mention and write down the definitions of all these switching times. So that is for the question. Demonstrate the working of half-wave rectifier with circuit diagram and waveform. First, define a rectifier. What are the types of rectifiers we have, and what is half-wave rectifier and why it is so called. So just mention that to few points and draw the half-wave rectifier circuit diagram. This is the half-wave rectifier circuit diagram. Explain the operation of half-wave rectifier. during the positive half cycle of input and during the negative half cycle of input. So what happens when the positive half cycle of input is applied? How the diode behaves? What is the current that is flowing through the load resistor? What will be the voltage across the load resistor? Just mention that when during the positive half cycle. So this is the output waveform. And what happens when during the negative half cycle of input? Just write down some few points. So this diode will be reverse biased. What happens if the diode is reverse biased? It is open circuited, so no current flows. As no current is flowing through the load resistor, the output is said to be 0. Just mentions a few points, how the circuit operates during the forward bias, how the circuit operates during the reverse bias. So just give the output waveforms of that half-wave rectifier. That's it. No other analysis part is required because he asked only to write down the, draw the circuit diagram and explain the operation with respect to the waveform. So just mention it. That's it. Now illustrate the transition capacitance and diffusion capacitance with suitable expression. So you just mention a PN junction diode. So what is happening when the forward bias, when it is forward bias, and what is happening when it is reverse bias? First of all, you mention what is a capacitance. Capacitance is nothing but when two oppositely charged plates are placed together, separating them by an insulating material, there exists a capacitance. Okay, so here the diode acts as capacitor under forward bias and also under reverse bias. The capacitance that is existing under forward bias is a diffusion capacitance. What do you mean by diffusion capacitance? What is the formula for diffusion capacitance? And just mention that this is the formula for diffusion capacitance. Mention each and every term in that formula and how it increases with the voltage applied. You just mention it. And then transition capacitance. This is a capacitance. This exists when the PN junction diode is reverse bias. Just explain some few points regarding the PN junction diode under reverse bias condition, how the junction is formed, what is the variation in the depletion layer width, and what is the amount of capacitance that is existing under reverse bias condition. So you just mention it and its formula and explain each and every terminology, like what is tau, what is ID, eta and VT. Just explain them. Okay, circuit diagrams are must, so that which are explaining the capacitance existing under forward bias and reverse biasing condition is very important. Draw the circuit diagrams and then explain what do you mean by transition capacitance and diffusion capacitance. Give the formulas. Okay, with each and every terminology used in that formula. Now illustrate the working of bridge full wave rectifier with circuit diagram and waveforms. So, similar to the half wave rectifier, you just define bridge rectifier, why it is so called, draw the bridge rectifier circuit, what happens during the positive half cycle. During the positive half cycle, this is the circuit diagram. Just explain a few points regarding the operation of bridge rectifier, which diodes are conducting, which diodes are non-conducting during the positive half cycle of input, and what is the amount of current and direction of current flowing through the load resistor, and what is the voltage drop across the load resistor. Just draw them using the waveforms. Okay, similarly explain the operation of bridge rectifier during the negative half cycle. This is during the negative half cycle. So what happens during the negative half cycles? Which diodes are conducting, which diodes are non-conducting. And then in both the cases, same amount of current and same direction is flowing, and hence you will be getting 2 half cycles of output also. So you have to explain this way. So you draw the finally output waveforms. What happens during the positive half cycle? Only D1 and D3 are conducting, and hence the current is flowing here. And during the negative half cycle, only D2 and D4 are conducting. And in both the cases, the same current is flowing through the load resistor in the same direction. So finally, this is the output current, that is IL is equals to I1 plus I2. Just if you mention these points, you will be getting the full marks. Now explain the difference between intrinsic and extrinsic semiconductor. So you all know that semiconductors are 2 types, intrinsic and extrinsic. Again, the extrinsic semiconductors are classified into 2 types, that is N-type and P-type. You just mention that classification and then you just define intrinsic semiconductor. So it is nothing but a pure form of semiconductor. So the examples of semiconductors are silicon and germanium. Just give it crystal structure of a pure semiconductor, how the bonds are formed, how the current conduction is taking place in intrinsic semiconductor. Just explain that. Okay, how the bonds will be broken and how the electrons and holes are created and how they are moving from one place to the other place. So that you just explain. Draw the crystal structure and explain the formation of bonds and when the bonds are broken and when how the current is flowing through the intrinsic semiconductor. Next, extrinsic semiconductor. So extrinsic semiconductors means adding some impurities to the pure semiconductor is known as extrinsic semiconductor. Just mention that point. And process of adding impurities is nothing but doping. So for how much amount of impurities are added, just mention that quantity. And what are the types of impurities that can be added here? We can add either trivalent impurities or pentavalent impurities. What happens if trivalent impurities are added? And what happens if pentavalent impurities are added? So that means N-type and P-type semiconductors are formed. So this is the crystal structure of N-type semiconductor. So just explain the crystal structure of this one by adding pentavalent impurities. So why it is so called? Why it is called as N-type? And because number of electrons are more, where electrons are negatively charged. So that is why this is called as negative type, in short, N-type semiconductor. Similarly, by adding trivalent impurities, holes are created where holes are positively charged. As it is having more number of holes, we are calling it as positive type or else P-type semiconductor. So just draw the crystal structures and why it is so called. Just explain few points how the current is flowing through the N-type and P-type semiconductor so that you will be getting full marks. Now discuss the following with respect to semiconductor. What is doping, dopant, donor and acceptor? So you all know this terminology. What do you mean by doping? Process of adding impurities is nothing but doping. So you just write down some points regarding doping, what kind of impurities that can be added, that all you mention. And dopant. So that means what are the impurities that are going to be added to the pure semiconductors are called as dopant. Okay. So what are the types of dopants that you can add? And donor. What is donor? Donor means it is donating an electron. It is known as donor. What kind of charge will be established on the donor atoms? And what is acceptor? What kind of charge is established once it is accepting the electrons? So donor means donating an electron, means it becomes positively charged. Once it has lost his negative charge, so it will becomes positively charged. That means donors are positive immobile ions, whereas acceptor are accepting the electrons and hence they become negatively charged. Okay, so you just mention few points, not only writing the definitions, you just mention some few points regarding that particular topic so that you can expect full marks. What is rectification efficiency? Derive the expression for the following half wave rectifier and full wave rectifier. So that means first you defined efficiency. What do you mean by efficiency? It is defined as a ratio of DC power delivered to the load to the AC input power from the transformer secondary. Just give the formula and try to derive the, you have the derivation. You can just go through my theory lecture, that is analysis of half wave rectifier you have. So you just go through that, and even analysis of full wave rectifier, that is mathematical analysis of full wave rectifier we have. So that lectures, you just go through them. You go through the derivation such that finally you have to get the equation for efficiency as 40.6 divided by 1 plus RF by RL. So this you have to derive. Okay. Then similarly for full wave rectifier. So first of all, for deriving that efficiency, we need to have RMS value of current and RMS value of voltage. And even we need to, from these, we need to calculate AC power delivered to the load and also the DC power delivered to the load. And then we have to get the we have to get the ratio so that you will be able to find out the efficiency of half wave rectifier and full wave rectifier. Now coming to the illustrate the working of full wave rectifier with circuit diagram and waveform. Illustrate means just explain. Means what? Again, define what do you mean by full wave rectifier. It is a center tap full wave rectifier. Unless it is mentioned as a full wave bridge rectifier, you need to write on the center tap full wave rectifier. If he is asking particularly a bridge rectifier, then you have to go for the bridge rectifier. So a rectifier circuit which can convert both the half cycle of input into DC is known as full wave rectifier. So this is the circuit diagram. Just mention the operation of full wave rectifier under during the positive half cycle. So with the neat circuit, if you explain, so you can get the full marks. So during the positive half cycle, this diode gets forward biased. During the negative half cycle, this diode gets forward biased. In both the cases, the current flowing in the load resistor in the same direction. So that is why we will be getting only positive half cycles of output voltage. So just give the output waveforms for the full wave rectifier like this, and that is a way of answering that question. Now find the terms that are referred to terms as referred to the half wave rectifier: efficiency, average or DC voltage, next ripple factor. So we need to derive these expressions. So just draw the half wave rectifier circuit diagram. Here I didn't draw, but whenever you are explaining the mathematical analysis, you have to draw the particular circuit diagram first. Okay. And then derive the equation for DC output. DC nothing but average. Average can be calculated by taking the integration. So over a complete period of cycle, that is 0 to 2 pi, just derive the average value of output current. From that you can calculate the output voltage, that is IDC into RL. So IDC is already known, Im by pi into RL. So just calculate this. And then efficiency, we all know that PDC by PAC, that is power delivered to the load by power input, AC input power from the transformer secondary. So we can also calculate PDC as PAC as VRMS into IRMS, and this PDC as VDC into IDC. Just substitute and derive the equation, this one. And after that, ripple factor, which is calculated as the ratio of RMS value of AC component to the average value of DC component. So that is VRMS by VDC. Just derive this value. So that is that means define a parameter and derive the value for that parameter. First define, write on the definition of efficiency. What do you mean by efficiency? DC value. What do you mean by DC value? Ripple factor. Write down the definition and do the derivation. Now, coming to the next one, find the terms referred to as full wave rectifier, PIV, TUF and ripple factor. TUF stands for transformer utilization factor. PIV stands for peak inverse voltage. So again, here also the same thing. Draw the circuit diagram of full wave rectifier. Write down some few points regarding the full wave rectifier. And define each and every factor. What is transformer utilization factor? How to derive it? What is the final value of a full transformer utilization factor for a full wave rectifier? Similarly, ripple factor. Define ripple factor and do the derivation. Finally, find out the ripple factor for full wave rectifier. So like that, every parameter you should define first and then derive the equation. Now the next one, find the ripple factor for the half wave rectifier with a shunt capacitance filter. So for this, first draw the half wave rectifier with shunt capacitance filter, circuit diagram. Okay, first draw the circuit diagram. What is the circuit diagram? So we have a transformer, as it is half wave rectifier. So we need to have only one diode, a resistance, and in parallel with resistance we have a capacitor. So this is the VI, that is Vm sin omega t. Okay, so this is the half wave rectifier circuit diagram, just with shunt capacitive filter. And derive the equation for shunt capacitive filter, that is this one. Okay, this is the equation for ripple factor of half wave rectifier with shunt capacitance filter. Not only writing the expression, you should do the derivation. Draw the circuit and do the derivation and explain the output waveforms also. Output waveforms for the given input, what is output across the capacitance, that you have to draw and then derive the expression for this. List the merits and demerits of half wave rectifier, full wave rectifier and bridge rectifier. So these are the comparison here. Just write on the parameter, half wave rectifier, full wave rectifier and bridge rectifier. Then write the applications of PN junction diode and explain how the PN junction diode acts as a switch. So these are the ideal characteristics and these are the practical characteristics. Just mention this ideal and practical characteristics. Under forward bias condition, the diode acts as a on switch, and under reverse bias condition, diode acts as off switch. This is under ideal condition, but in practice, we do have some cutting voltage. Okay, so this you have to mention. And coming to the applications, we have various applications of diode. So just mention all the applications here like this. So this is how you can answer the question. So that's all for this lecture. I hope it is clear to you all. Now you can answer any kind of question that may be asked from the first module, that is on PN junction diode and rectifiers. And even you can solve any problems that are given on diodes and rectifiers. I hope it is clear to you all. That's all for this lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.